হ্যালো মাই ডিয়ার স্টুডেন্টস, আমরা আজকে প্রবলেম নাম্বার 8 থেকে স্টার্ট করব ওয়েল্ডিং কানেকশনের। তো প্রবলেম নাম্বার 8 ইজ এ টাই মেম্বার অফ এ ট্রাস কনসিস্ট অফ ডাবল অ্যাঙ্গেল সেকশন ইচ 80-88. This is equal angle section 80-80 equal angle section welded on the opposite side of 12 millimeter thick gusset plate as shown in the figure. This gusset plate is 12 millimeter thick and this is one angle, and behind this gusset plate there is another angle. Okay, both. And this is the gusset plate. Gusset plate thickness is 12 millimeter. So design a fillet weld for making the connection in workshop. That means shop welding. We have to consider that the shop welding when we are choosing the factor of safety. The factor tensile force in the member is 300 kilonewton. So to design this welding, first of all we need Fe410 grade of steel, and for shop welding partial safety factor gamma MW 1.25 from table 5 IS 800. So from table 5 gamma MW for shop welding 1.25. Okay, and the another properties we require, that is ISA 8088. For ISA 888 from handbook we need this CZZ value. Go to handbook. This is rolled steel equal angle section. Equal angle means this length and this length should be same, or 8088. So ISA 8080, this is the section and thickness is 8. Okay, for this section CZZ is 9.6. No, sorry, CZZ is this line, this column 2.27. So 2.27 centimeter, that means 22.7 millimeter. Now let us consider the welding length at top edge is LW1 and bottom edge is LW2. Okay, now total welding length is, for one side LW1 plus LW1 plus LW2 plus LW2. So LW1 plus LW2 into 2 for both angle. Minimum size of weld is 5 millimeter. We are considering. Why? From table 21 we can see, from table 21 where the plate thickness is greater than 10 and less than 20. So the minimum size of weld should be 5 millimeter. And maximum size of weld should be thickness of thinner member minus 1.25. This is from figure 17A of IS 800. Thickness of minimum thickness of member minus 1.5. Thickness of thinner member minus 1.5, so 6.5. Let us provide 5 millimeter welding size, and effective thread thickness KS 0.7 into 5. 5 is welding size and K value is 0.07 from table 22 of IS 800. This K value is for 60 to 90 degree. This is 0.7. K value is 0.7. So per millimeter length welding strength should be this. The formula is, we are applying this formula. So LW should be 1 because per millimeter length we are considering. So LW is equal to 1, TT effective throat thickness, TT is equal to 3.5, and FU value is 410, and MW, gamma MW is equal to 1.25. So per millimeter length welding size is, strength is 662.79 Newton per millimeter. So total design strength should be equal to factorial tensile force, and total force, applying force is 300 kilonewton. Factorial tensile force is 300 kilonewton. So to resist 300 kilonewton, we should equal the design strength with factorial tensile force. So design strength should is equal to per millimeter length strength 662.79 into total length of the weld. This is the total length of the weld. We have already calculated 2 into L1 plus L2. Okay, 2 into L1 plus L2, total length equal to factorial tensile force. So L1 plus L2 is equal to this, and to calculate L1 and L2 separately, we have to taking moment about any edge. So if we taking moment about lower side or lower edge, okay, now taking moment about this point. So force, suppose P1 force into LW1, P1 force into LW1, this is toward left, consider this figure, toward left, force P1 into total distance is 80. So P1 into 80 is equal to, this is anti-clockwise moment, is equal to clockwise moment. Clockwise moment should be 300 into this distance, because 300 kilonewton is applying through the CG of this angle. Okay, now from bottom line XX to the CG distance is CZZ 2.27. okay, now if we taking moment about this lower edge, so P1 into LW1 is equal to 300 into 22.7. okay, so P1 force should be 662.79 into 2 into LW1. 2 why? 2 is for both angle, okay, into 80 is the distance, is equal to 300 into 10 to the power 3, this is force, into CG distance from bottom 22.7. So L1 is equal to 64.21 millimeter, approximately 65 millimeter we are considering. So L2 is equal to total length 226.31 minus 65 is equal to 165 millimeter. So one welding length should be 65, another 165. So this is 65 and this length is 165 millimeter. Is 65 millimeter. Okay. So that was problem number 8. And problem number 9 is an ISLC Indian standard ISLC 300 at the rate 324.7 Newton per meter Fe410 grade of steel is to carry a factorial tensile force of 900 kilonewton. The channel section is to be welded at side to a gusset plate 12 mm thick. Design a fillet weld if the overlap is limited to 350 mm. overlap is 350 millimeter. We cannot provide greater than this value. Okay. Now, if 410, Fy value is 250 and F is equal to 410. For site weld, this is in the question it is given that it should be field fabrication. So for site weld, factor partial safety factor gamma mw is equal to 1.5 from table 5, and from handbook for this ISLC 300 we need cross section and resistance and TF and TW. Go to page number 6 of rolled steel channel. Okay, ISLC 300, this one ISLC 300, AG is equal to 33.1 AG is equal to sectional area 42.11 centimeter square, 42.11 centimeter square AG. So 4211 millimeter square. TF is equal to 11.6 millimeter. TF is equal to 11.6 and TW is equal to 6.7. TW is equal to 6.7. So minimum size of weld is 5 millimeter. We are considering because the plate thickness is 12 millimeter, is greater than 10 and less than 20. So welding sizes should be, minimum size should be 5 millimeter, and maximum size, thickness of the thinner member minus 1.5, thinner member is 6.7, that is angle, thickness of the angle, thickness of the channel is 6.7. This is the thickness, welding web thickness, and flange thickness is greater than web thickness. So minimum thickness is 6.7 minus 1.5, that is 5.2 millimeter, and we are providing 5 millimeter welding size. So effective thread thickness is Ks is equal to 0.7 into welding size 0.7, because K is equal to 0.7 from table 22. So per millimeter for strength of weld per millimeter length is, we are calculating, that is 552.33 Newton per millimeter. So total design strength should be equal to factorize tensile force, and total length of the weld into total length of the weld into per meter strength of per meter length is equal to factorize tensile force 900. This is given 900 kilonewton. So LW1 is equal to 1630 millimeter. Now what should be the length of the weld? We can use this side parallelly and this side also. Okay. So 350 plus 300 plus 350. Now first trial is, if we do that 350 into 2 plus 300, then total length is 1000 millimeter, which is not sufficient. We need 1630 millimeter. So we have to go to slot weld. For slot weld, we need some slot, and slot width, that is this is the slot, and this width of the slot is should not be less than 25 millimeter, and this restriction you can find from IS 816/1969. Go to this clause 6.2.8.1. First of all, download this code IS816 from Google and go to clause 6.2.8.1, and you can find that it should be 3 into thickness. Thickness is 6.7 for this channel section, and 25 millimeter, whichever is greater. 3 into 6.7 and 25, whichever is greater. This slot should not be less than this. So we are considering 25 millimeter. Let us provide 2 slot. If we provide 2 slot here, 2 slot, then (1630) total length is equal to 2 into 350 plus 300 into 4, 300 plus 4 into LS. 2 into 350 means this 350 and this 350. So 2 into 350 plus 300. Why plus 300? Because this distance, this is total 300 distance. We are actually providing total 300 millimeter. That is this length plus this length plus this length plus this length plus this length. So total vertical length is 300. Now we need to calculate only this length, this length and this length and this length. That's why we are assuming that this length is LS. Okay, so 1, 2, 3, 4. So 4 into LS plus 300 plus 350 plus 350. This is total 1630. So 1630 is equal to 2 into 350 plus 300 plus 4 into LS. So LS is equal to 157.5, approximately 158 millimeter. So we are providing 158 millimeter into 25 millimeter slot. So 158 millimeter, which one is 150 millimeter? This is 150. This is 150. This is 150 length. This is 150 length. Okay. So 350 plus 150 plus 25 plus 150 plus 150 plus 25 plus 150 plus this plus this plus this. Total 1630 millimeter building length. Okay. Now I stopped here, and from next video we are going to discuss about tension member. Okay.